Hello everyone, this is Akhil Reddy Cherukupalli. I have chosen the project Preventive Multi-Master Replication in a cluster of autonomous databases for the operating system. Abstract. So this study presents a strategy of replicating data across multi-masters over a group of systems that are geographically separated from one another. So the primary goal of data replication is the vast majority of situations is to produce a copy of the data that is indistinguishable from the original in each and every database node, and also utilizing a method known as multi-master replication, which is also known as advanced replication or symmetric replication. Depending on the context, you are able to store many data sets in a variety of places. So basically, data replication solution assures strong consistency for parallel query processing in a cluster of autonomous databases. So there are basically two basic approaches to manage data replication. They are eager replication and lazy replication. With the eager replication, it allows read one, write all, and whenever a transaction updates one replica, all other replicas are updated inside the same transaction. Therefore, mutual consistency of replicas and strong consistency are enforced. But with the lazy replication, a transaction can commit after updating one replica copy at some node. So after the transaction commits, the updates are propagated to the other replicas, and these replicas are updated in separate transactions, where the eager replication is together and the lazy replication is separate transaction. And the property of mutual consistency is relaxed and strong consistency is assured in here. And lazy replication is easy deployment, and it also gain something like interest because has the mechanism to refresh data in several emerging distributed application environments. And in the lazy replication, a primary copy is stored at master node and secondary copies are stored at slave nodes, and there is a copy that might be stored and updated by different master nodes. Then it is called as multi-owner copy because there are different type of masters, but they are stored in the multi-owner nodes, and it is known as multi-master configuration. And it consists of multi-owner nodes which are on a common set of multi-owner copies. These are two prepositions included in the paper which are proved in the further slides. They are if two multi-owner transactions say MOT1 and MOT2 are said to be executed in total order, then if all the multi-owner nodes that commits both MOT1 and MOT commit them in the same order only. And for the cluster configuration that meets a multi-master configuration requirement, then they use the refresh algorithm that C uses. It's correct, and if and only the algorithm enforces the total order. So this is a figure 1, the cluster architecture. In these we can see there are each cluster node is composed of 5 layers, and they are a request router, application manager, transaction load balancer, replication manager, and the other one is DBMS, that's database. And then a request may be a query or update transaction on a specific application. So the general process is when a user request arrives at the cluster, then it traditionally through an access node, and then it process to it sends randomly to a cluster node. Then if there is no significant data processing at the access node, to avoid bottlenecks, within the cluster node, the user is authenticated and authorized through the request router available at each node. We can see in the picture. And then the router available at each node is by using a multi-threaded global using the directory service, it is accepted. And then the request router chooses a node J to submit the request. So after that, the request router, it routes to the user request to an application node, and by using the traditional load balancing algorithm. Multi-owner node architecture. So to implement the multi-master refresher algorithm in a multi-owner node, we assume 6 components that are added to the regular database. And so here our goal is to maintain node autonomy, since because the implementation solution does not require the knowledge of system terminals. So the figure shows all architecture components necessary to implement our algorithm. The replica interface manages the incoming multi-owner transaction submission, and the receiver and propagator, they implement like reception and propagation of messages respectively. And the refresher, it implements the multi-master refreshment algorithm. And the deliver, it delivers like the submission of multi-owner transactions to the local transaction manager in first out order by using a running queue. So in like these following, we focus on the replica interface and refresher components. Performance parameters. So in these, we vary multi-owner transactions arrival rates, like it is noted as lambda, and define like two type of multi-owner transactions denoted by the MOT, multi-owner transactions, and then it defined by like number of write operations. So basically small transactions have size while along other more than like large transactions have size 50. So like to understand this behavior of the algorithm, it is represented as like short and long transactions, and they define like 4 scenarios. And the first one is like long transactions ratio denoted by LTR, and next one like defined in the terms of like if LTR is like 0, all updated transactions are short, and when it's 30% of updates are long, and it's 60% of update transactions are long. If it is 100, everything like all update transactions are long. And then like we have the NB multi-owner, it defines the multi-owner nodes. And for example, like to simulate 8 multi-owners, each cluster node carries 2 replicator instances by the memory management, and it may comprise like our results. So for the fairness, like we consider like a equal number of multi-owner instances at each node. And finally the single table which has 2 attributes and carry 1000 tuples and no indexes. This picture displays the performance results clearly, like for all showing LTR values and the scalability is achieved. So in fact, like for each LTR value, the response times corresponded to the average transaction response time. We can see clearly in the picture like the difference in response times in a function of the LTR transaction, and the highest the LTR value, there are higher responses, because due to like size of transactions and the bursty overload, the running queue, it is known as it is used by the deliverer to submit multi-owner transactions, becomes a bottleneck for transaction processing, because since the transaction submission is done sequentially. So as an average response times are much high compared to the low workload scenario. The algorithm still scales up since the network delay introduced to a multicast message is very small and avoiding network contention. And furthermore, like in contrast with the synchronous algorithms, we have like our algorithm has like linear response time behavior, because it requires only the multicast of particular like n messages for each coming multi-owner transaction, where n corresponds to the number of nodes. Motivation. When it comes to multi-master replication, the issue of data inconsistency is by far the most common reason for its failure. And then in addition, because of these, the utmost importance to ensure that multi-master systems continue to function appropriately and normally despite the presence of a wide range of unforeseen problems or Byzantine faults. This is actually because it is essential to ensure that multi-master systems continue to function appropriately and normally. Methodology. So in this strategy, master replicas do not participate in indirect communication with one another, but they function in a way that is completely independent. So like in contrast, every replica is an independent system, is checked. Whenever a read query is executed, the system will provide only a single response. if at like 50% of the computers that are part of the system answer in the same manner. So if any read query executed, at least most half of the systems will execute in the same manner. So due to these facts, we know that like the knowledge of the population rather than the output of a single institution, this technique eliminates the Byzantine fault as well as the data inconsistency instantly. Expected results. So this project aims to achieve like following process, like investigation the processes and techniques for multi-master replication that are currently in place, and then research has to be done on the performance of various designs, like as well as the resilience of present architectures or to data inconsistency and Byzantine fault. And also they consider like novel idea and put that idea into action, like in order to put into action like multi-master replication that is both effective and efficient. References for the paper. Thank you everyone. If you have any questions, please let me know through Discord.